Hello, everybody. Welcome to Truro, Nova Scotia, Canada. My name is Zeyu Zhang. I'm a master's student working in Dr. Stephanie Colombo's lab. And today I'm presenting my study, omega-3 long-chain polyunsaturated fatty acid, omega-3 LC-PUFA synthesis in landlocked salmon compared to farmed Atlantic salmon. And Atlantic salmon are well known for their nutrition value of omega-3 fatty acids, which are EPA and DHA for our human consumption. Canada is one of the major Atlantic salmon producers in the world, including Norway, Chile, the United Kingdom. In Canada, salmon aquaculture represents 80% of total finfish aquaculture. Aquaculture industry plays an important role in the Canadian coastline area. And here you can see, here's a map showing the coastline area in Nova Scotia, kind of give you the idea of the scale of the aquaculture industry in Nova Scotia. And salmon farming consumes a large amount of fish oil to make salmon feed pellets. Fish oil sourced from wild small fish, such as herring, anchovy, sardines, is the most nutritious and digestible ingredient, and also a major dietary lipid source of EPA and DHA for salmon. And however, because of limited supply of wild small fish, the cost of fish oil is high and unstable. And you can see from this figure, the price of fish oil is shown in the blue line. The price could be 2 to 3 times higher than soybean oil for the last decade, from 2011 to 2020. And it turns out the way that we obtain the fish oil to make salmon feed pellets is unsustainable. And the solution to this problem is to replace the expensive fish oil by cheaper vegetable oils. And therefore, researchers have been working on it for the last few decades. But there is a limitation in vegetable oil, which is lacking dietary omega-3 LC-PUFA, EPA, and DHA. Feeding salmon with the pellets that only have vegetable oil in it might affect the EPA and DHA content in the final product, in the final salmon product in the market. So why it's important to supply EPA and DHA to salmon? And from the perspective of fish nutrition, EPA and DHA are essential fatty acids, which mean fish cannot fully synthesize by themselves. So farmed Atlantic salmon require 1 to 2% of EPA and DHA in their diet. And the shortage of EPA and DHA in fish might cause the health problems such as the impaired vision and reduce the growth performance and reduce reproductive potential. And also the decrease of EPA and DHA level in fish also affect the market value of salmon. Therefore, vegetable oil cannot fully replace fish oil. So introducing a freshwater strain salmon with enhanced EPA and DHA production can solve the limitation of using the vegetable oil. As you can see from the left figure, Atlantic salmon usually live in fresh water when they are young, and they swim to the ocean for growing up. But the freshwater strain salmon, which is also called the landlocked strain salmon, they are able to live their whole life in fresh water, and they are widely found in North America and Europe. Freshwater environment is short of omega-3 LC-PUFA, EPA, and DHA in the food web, which means freshwater strain salmon need to produce more EPA and DHA by themselves. Researchers believe freshwater landlocked salmon have a better bioconversion of EPA and DHA than farm salmon. So my research objective is to enhance or improve the EPA and DHA synthesis in commercial strain Atlantic salmon by determining if freshwater landlocked salmon produce and store EPA and DHA better than the commercial strain salmon when fed a fish oil-free diet. And in the method, so two salmons, freshwater landlocked salmon and a farm salmon were compared, and they are fed two different diets. One diet had fish oil, which is a controlled diet, and the other diet only had vegetable oil in it, so it's a fish oil-free diet. And after 16 weeks feeding, I look at the growth performance of the two strains of salmon and their fatty acid content in the muscle and liver. So briefly, you can see the results. The weight gain results suggested that landlocked salmon can effectively use a fish oil-free diet, which is low in EPA and DHA, and have a similar weight gain compared to commercial strain salmon fed either diet. There's no significantly differences between these three treatments. As for EPA and DHA, the content of EPA and DHA in the fish muscle and liver were not significantly different between the two salmon strains when fed the fish oil-free diet. So overall, the landlocked salmon have a genetic potential to use a fish oil-free diet more efficiently than commercial strain salmon with regards to long-chain polyunsaturated fatty acid synthesis. And my next step is to investigate if there are some salmon from different families within the commercial strain which have better EPA and DHA biosynthesis. In the future, with the help of our selective breeding research, I believe Atlantic salmon can be raised by only plant-based ingredients and still can produce good amount of EPA and DHA. And that is how we achieve the goal of sustainable aquaculture. Oh, thank you for the attention.